So this is that moment. Okay, we're about to step fully through that threshold across which we cannot come back. We're going to be rocket scientists. Just go ahead. We're going to be rocket scientists here in a moment. So there we have it, right? So two types of rockets. There are basically two types of rockets. Well, three maybe. I don't know. Okay, there's four. No, there's five. Seven. There are two basic kinds if you ignore ion rockets. We'll talk about ion rockets too. Okay, but there are solid fuel engines, and these have been around for hundreds of years. Yes, the rocket's red glare, at least since the Revolutionary War. Yes. Okay, or was that from the War of 1812? Rocket's red glare. We should know this. But anyway, it was from 1812. Yeah, there we have it. But anyway. These things have been around. The Chinese invented solid fuel rockets, maybe not as sophisticated as this, but the basic idea is you have stuff in here that burns really fast. The exhaust gases fly that way, and the basic idea is that if I propel something that way, okay, it will, come flying back at me. No, if I throw something that way, it pushes me back the other way. Yes? And I can do that in space. If I shoot molecules that way, the molecules push me this way. And there's no sense really that we have to push off of something other than the molecules that we just send flying into space, right? Okay. And I decided that I was going to build my own solid fuel rocket. By the way, never do that. Okay. So I used a casing. I used a steel pipe as my casing. Yeah? Because that's a real strong casing. And I put a pipe cap on this end, and I drilled a hole in the pipe cap. Yeah, right. And and that was going to be my nozzle. Right. That's going to be a good nozzle, don't you think? Yeah. And I filled this space with what I thought was the right stuff. This was shotgun shell powder. Now, don't get me wrong. Shotgun shell powder, black powder. If you put a little bit of it on the table and light it, your ears ring. I mean, it just goes bang. It's amazing, right? Okay, shotgun shell powder, though, I could lay like stuff of it, I pour it on the counter and light it on one end, and it would burn like a fuse, kind of shh, like that. Isn't that something? Very, very unbangy, right? So wouldn't that seem like it would work as a rocket fuel? Wouldn't it? Yeah. Never mind that it explodes violently, by the way, in the barrel of a shotgun. Yeah? I wasn't really, I was like in 9th grade or something like that, so not, maybe the sharpest knife in the drawer, right? So I was smart enough, though, by the way, not to be anywhere near this when the fuse burned down. So I stuck a fuse in there and set it up, ran far, far away, and yes, I made a pipe bomb. Okay, the thing exploded violently. Chunks of metal flew through the trees and sawed off branches, like not small branches or twigs, but like things as big as my finger were sawed through by the shrapnel. Things fell out of the trees. A piece of it hit like a metal shed in someone's backyard and made this loud BAM sound, right? Yeah? Okay. And the neighbors called the police called the FBI, and later that summer an FBI agent, honest to God, came knocking on my door, and I was like gone to like Boy Scout camp of all places. And but I'm sure that if I ever ran for like public office, there would be like something in my file that would say no. I can't do that, right? Okay. But these are solid fuel rockets are incredibly robust. Technology. I'll pass a couple of these around. These are solid fuel rockets without the solid fuel left in them. Okay, so you can kind of smell where it's basically gunpowder, but it's made so that it doesn't explode, right? Okay. And then you can also look at the nozzle. I imagine that the nozzle here is made of clay. The casing is just paper, right? But it's really, really strong paper. In fact, and this would be wrong to do this, but when I taught at the Indian school, we had this whole lesson where we built model rockets like this and launched them and chased them down, and this was wildly fun. But when a rocket finally needed a burial, it was going to die. We taped the wings, the fins on the last time, and the rocket bodies eventually get kind of soft because they crash into the ground and this and that, right? Okay. When we wanted to give them a burial at sea, what we would do is we would fill this full of black powder, put an epoxy in the end here, like glue, right? And then stick it as the second stage or instead of the parachute, and just send it up there. Yeah. And these things make just fine explosives. Like they sound like an M80, not quite as loud. M80s are those things that go flashbang at the fireworks shows. Yeah, don't do that either. Okay, but there you have it. You pass that around. Now the nice thing about solid fuel engines is that they can sit. You can stick a solid fuel engine in your backpack, hike around in the desert, and if you need to kill a helicopter with it, right, you can pull it out of your backpack, load it into the launcher, go, and it goes. You light it and it goes. Isn't that a wonderful thing? This is, by the way, I'm talking about Afghanistan. Have you guys seen Joe Wilson's war? This is it a senator or a congressman? Charlie, is it Charlie? Joe Wilson's the guy. Yeah, Joe Wilson it's Charlie Wilson's war. There we go. Two different Wilsons, two different stories, right? Charlie Wilson's story. Yeah. Where the guy, where he arms the guys with those missiles. That's how those missiles ran. They had solid fuel engines, right? Okay. These right here are the largest solid fuel engines ever built. Okay. These are the solid fuel boosters for the space shuttle. Without them, it's not going to make it into orbit. Most of the thrust is being provided by the liquid fuel engines of the main engines there. And then this thing, you can't really see it, but that enormous red tank, okay, that enormous thing has all the fuel to run the main engines here. But without these guys, it's not going to make it up into space. These things are made in segments. Really, if you were going to build this, you would make it all one piece of metal. But we had to make them in segments because they have to sit on railroad cars and go from I think Utah. They have to get from Utah to where they launched them in Cape Canaveral, right? And because they are sectioned like that, that was the Challenger failure, is one of those O-rings that seals those things together. One of them failed because they launched it too cold, and the hot gases came out of this, hit that tank full of hydrogen and oxygen fuel, and it went boom. And we have a question.
Like when you see like the engines like fall off like the rocket or whatever, like when they're in space, like
yeah,
does it just like deteriorate?
Yeah, the ones that get up high enough in the atmosphere, they'll burn up, right?
Like
some of them, these guys fall into the ocean, and we reclaim them and try to remake them round again and reuse them,
so they like
right?
they let them go like when they're over the ocean.
Yeah. That's, if you look at they're launching toward the east because that's a
boat,
yeah. Don't be on a boat right there, Yeah, I know. Like, okay, now take a look at this expression. If I take the force times time equals mass times change in velocity, and I rearrange it and solve it for the force, don't I get force is mass times velocity over time? Yeah? Okay. So if you're a rocket engineer, the key to making a very good rocket, one that gives your whatever you attach it to a lot of thrust, right, is that you've got to have, well, you want to make this as small as possible. You want to burn the fuel as slowly as you can so it lasts as long as possible. And the only way to do that is to have a tremendous exhaust velocity, yes? Those rocket engines you're passing around have an exhaust velocity of about 700, 800 meters per second, as far as we can tell from our calculations. Okay? Because we used to test them. We used to set them outside and actually put force probes on them and test them. The Saturn V rockets, these are really big fancy rockets, had exhaust velocities of 2,000 plus meters per second. So the bigger this is, the bigger the thrust you're going to get. Now, here's the catch. The bigger your exhaust gas velocity is, the bigger the pressure has to be in there. So a well-engineered rocket engine is just this side of going boom, yeah? If it's too safe, it's too heavy and it's not good. And if it's not safe enough, it explodes, right? Yeah? So there's a trade-off. Yeah, I don't know if it's twice as expensive or whatever. You just put them on the front counter there.
Is that a Saturn rocket?
No, you'll see. I'll show you this. Okay, now here is, how many people have seen this sheet of paper? This sheet of paper, how many people have launched a model rocket before? Yes. Okay, in the model rocket there's a little bit of paper. Isn't it all kind of folded up in there? Yes?
Yeah.
Yes, you take it out. It's like, where are the rocket engines? Yes? Okay, no. Okay. On that sheet of paper, they've got all this data. They've got these data tables because you guys are little scientists. You're not just little pyromaniacs that want to launch things up into the sky and chase them, right? Isn't that right? Okay. So here it is. Here's the data that they give for this. This is force. This is time here. Okay. Notice that most of the engines burn out. Most of the engines burn out before 2 seconds or maybe just slightly after 2 seconds. right? So they don't burn for long.